Hello everybody, welcome to this channel. I'm Peyman Hisari. In this video, I'm going to implement logistic regression on Titanic dataset to predict whether a passenger will survive or not. The link to the dataset is in the description. To start, let's bring the dataset into the process panel. Take a look at the data. As you see, we have 891 data points with 12 regular attributes. Some attributes like passenger ID, name, and tickets are redundant. They have no information. And our target variable is survived, and it is 0, 1. The data type is integer. Because we're going to build a classification, we have to convert the data type from integer to categorical. Also, some features like sex and embarked are categorical. Machine learning models do not understand these categorical variables, so we have to convert them into numerical. And there are some missing values in age, so we have to take care of them. So let's first remove those unwanted feature using an operator called select attribute. Bring the operator here and configure this one. The type is going to be include. The attribute filter type, I'm going to use a subset. And the select subset, I'm going to choose those features that I'm going to use. Apply. And if I run this process, then I should have only those features. And now I have only 8 features. Next, I'm going to change the data type of the survived or target variable using an operator called numerical to polynomial. Bring the operator here, connect these two operators together, and configure this one. Attribute filter type is going to be single because we're going to change the data type of only one column. And the attribute name is going to be survived. Next, I'm going to tell RapidMiner that this survived column is my target variable. In order to do that, I use an operator called setRow. Bring the setRow operator here. Connect these two operators and configure this one. Click on Edit List. The attribute name is survived, and the target role is going to be label. Next, I'm going to split the data into 2 subsets, one subset for training, another one for test. And in order to do that, I use an operator called split data. Bring the operator here and configure this one. Partitions, you need to add entry. The first partition I'm going to use for training, and I use 70% of the data or 0.7. Add another entry, and that is going to be 0.3 or 30%. And keep in mind that the sum of these two numbers is equal 1 or 100% of the data. Okay. And the sampling type, we have different ways that we can sample from the data set. I'm going to use automatic, and in order to reproduce the same data set, no matter how many times I run the process, I use local random seed, and it is set by default to 1992, and I leave it as it is. Next, I'm going to convert the categorical variables into numeric using an operator called nominal to numerical. Bring the operator here. Connect these two operators together and configure this one. The attribute filter type is going to be subset, and those attributes going to be embarked and sex. And the coding type, I'm going to use dummy encoding. And in order to get rid of collinearity, I use comparison group, and comparison groups, click on edit list. And for the embarked, I'm going to choose C and add another entry. And for sex, I'm going to choose female. Apply. And if I take a look at the result now, you see that I don't have categorical variables anymore. Next, I'm going to take care of missing values. And in order to do that, I use an operator called replace missing values. Bring operator here. Connect these two operators together and configure this one. And the attribute filter type is going to be single. And the attribute name is going to be age. And we can use the default as average, which means that we replace those missing values with the average value of age column. And if I run this process again and take a look at the results, for example, age, there is no missing value anymore. Now my data is ready, and I'm going to build my model using logistic regression operator. Bring the logistic regression operator here. Connect it with the operator. And again, I'm not going to change anything because this is my first attempt, and take a look at the performance. If it is not satisfactory, I can come back and change those hyperparameters. And I'm going to make a copy of this logistic regression model because I need to use it more than once. And in order to make a copy, I use an operator called multiply. And bring the multiply operator here and connect it with the model. MOD stands for model. And this just make a copy of the logistic regression model, and it has nothing to configure. Next, I'm going to calculate the performance of the model on training set. And in order to do that, I need to apply model on the training set using apply model operator. Bring the operator here. And as you see, this one has two input. One is model, which should comes from the multiply because this is my model. And the other one is unlabeled data, which comes from the logistic regression operator, which basically it is the training set. And apply model has nothing to configure. Next, I'm going to calculate the performance using performance operator. Bring the performance operator here, connect these two operators together, and configure this one. Main criterion I'm going to use first, and the first criterion is accuracy. You can add as many of this metric as you want based on the problem that you have. And if I connect this one to the output and run the process, I will have my performance of the model on the training set. So this is the performance of the model on the training set. Next, I'm going to calculate the performance of the model on the test data. In order to do that, I have to apply the same pre-processing steps that we did on the training set to the test data. So in order to do that, I come back here and apply the conversion of the categorical variables to numerical on the test data as well, and take care of missing values on the test data as well. So in order to do that, I use an operator called apply model. Bring the apply model operator here. The data should come from the split data second output or second partition. This is the test data. And we have to use this output of the nominal to numerical, because this will make sure that the same conversion that has been done on the training data will be applied on the test data. I can rename this one using F2, and I can rename it as apply model. This is categorical to numerical. Next, I'm going to take care of missing values on the test data. So I have to do the same on the missing value in the test data. So I use apply model. The data should come from this operator, and the model should come from this missing operator. So it makes sure that the same operator that has been done on the training data should be done on the test data as well. I rename this one as well. So this is taking care of missing values. And finally, I need to apply the logistic regression model on this data, again, using apply model. And again, data coming from this operator, and the logistic regression models comes from this operator. And I can rename this one as test data. So this is apply model on test data. And I need to calculate the performance. I can copy and paste this one. Connect these two operators together and rename this one as performance for test data. I can connect this one to the output as well and rename this one as well. This is performance for training. And if I run the process, I should be able to see the performance of the model on both training set and test set. So this is the performance of the model on the training set. I have 82% accuracy. And this is the performance of the model on the test set, and I have about 80% accuracy.